All right, hey Algebra 2, here is our first video covering section 2.2. We're looking at slope and rate of change. Hopefully this is pretty much review for you, although Algebra 1 was a few years ago, so that's kind of why we got to cover this material so we can get a little bit of a refresher, okay? So the first thing we want to talk about is our slope. Go ahead and take a little bit of time. You can pause the video. Just go ahead and write down this definition. The slope, and we denote slope as the letter M of a line, so the lines that we graph on our coordinate plane, is the ratio. So if you remember what ratio is, it's we're comparing two numbers, usually represented in a fraction form, okay? A ratio of vertical change, so you might have heard slope as rise over run. The vertical change is the rise, to horizontal change, which is our run. Okay, so how much does this line go up or down, right? Despite it being called rise, it refers to how up or down it goes, divided by the horizontal movement, which we usually go from left to right. Okay, we have an equation for slope. M equals, if you remember, y2 minus y1 over x2 minus x1. Okay? And that kind of matches with our idea of rise over run. When we think about our x1, y1, x2, y2, those are the ordered pairs on the coordinate plane for which we're finding the slope. So here's our x1, y1, and here's our x2, y2. Remember, this is our y-axis, and this is our x-axis. Okay? So pretty much what y2 minus y1 represents is the height of this ordered pair minus the height of this ordered pair. And that, graphically, is this distance right here. Okay, this is our rise, or our y2 minus y1. Physically, that's the distance. When you subtract them, you numerically get the distance. Okay? And then that's the same idea with our run. It's the x2, so it's from the y-axis, the 0, the x equals 0 value, from there to our x2, minus from our y-axis to our x1. When we subtract those two, we get this distance physically, or graphically, and that's our run, x2 minus x1. Okay? So that's how slope works, and remember, this very well could have been different. This line could have been going down, and our rise would have been negative. It would have went down because our y1 value would have been bigger than our y2 value. Okay? So why don't we just give that a try really quick. So for our first example, go ahead and pause the video if you need to, and write down this right here. Given a line, graph a line between the following points on the coordinate plane. Calculate the slope of the line, so we're looking for slope. And we're going to classify the slope as well. We'll talk about that. We'll talk about what that means once we get to it. Okay, so we're doing three things actually. We're graphing the line, so we want to make sure we know how to graph our line still. And then we want to calculate our slope and classify it as well. So graph, calculate slope, classify. Okay, so let's go ahead and start with A. So we have from -5, 1 to 3, 1. Go ahead and create a little coordinate plane. Judging by my values, since I have a negative x value and a positive x value, I'm going to need both sides of the y-axis. Since both of my y values are positives, I really only need the top of it. So I'm just going to show this much of the coordinate plane. Okay, so we're going to go out to -5, so I need that many tick marks. 3, 4, 5, and we'll do 6 just to get all the way to the end of the line. 2, 3, 4, 5, 6. And we only really need to go to 1, but let's just be consistent. Let's tick these out as far as we can. And let's graph our points. -5, 1. We're going to go to -5 on our x-axis. So 1, 2, 3, 4, -5, 1. So here's our ordered pair. and then 3 comma 1. 1, 2, 3, 1, and then connect it. I'm using this Cane's gift card. I'm not really going to Cane's anytime soon, so the next best way to use it is as a ruler. Connect the dots with a nice line. Cool, there's our line. Let's go ahead and calculate the slope now. So we're going to use that formula we have up here, y2 minus y1 to get our rise, x2 minus x1 to get our run. So, and again, if you remember from Algebra 1, it doesn't really matter which one you label as x1, y1, x2, y2, as long as you stay consistent when you use the formula, okay? Just to kind of show you that it doesn't matter, I'm going to label the first one x2, y2, and the second one x1, y1. So then let me do my y2 minus y, or let's just find the slope, right? M equals y2, which is 1, minus 1, divided by x2 minus x1. So negative 5 minus 3 equals 1 minus 1 is 0. Negative 5 minus 3, that's negative 8. 0 divided by negative 8, that gives us the big fat 0. So our slope is 0. Okay? And what that means is that whenever you have a 0 slope, you're going to get this horizontal line, which means that it runs forever because we have a negative 8 as our run, but then it never rises. The fact that we got 0 for y2 minus y1 tells us that it never rises, and so that's why it's a horizontal line. Okay? So the way we classify the slope is, well, it's just 0, so we say 0. We can also say that it's a horizontal line. Okay? Let's try another one. I'll go ahead and do one more of these with you, and then try the other two on your own. So let's go ahead and try part B. Same kind of idea. We're going to go to negative 6 on the x-axis, negative 4 on the y-axis, so might as well just give ourselves the entire plane. Okay, I'm not using my ruler, so I'm kind of not using my resources. You should use your resources to make nice lines, unlike me. So 1, 2, 3, 4, 5. We're going to go to negative 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, negative 6 comma 0. 1, 2, 3, 4, 5, negative 6 comma 0, so we're staying on the x-axis, and 2 comma negative 4. 1, 2, 1, 2, 3, negative 4. Using our Cane's ruler. There's our beautiful line. Now let's go ahead and calculate the slope. Okay, so y2 minus y1, I can, I'll switch it up again to show you that it does work both ways. So this is x1, y1, x2, y2. Negative 4 minus 0 divided by 2 minus negative 6. Be careful with your signs here, okay? So numerator, negative 4, because negative 4 minus 0 is just itself. 2 minus negative. I'm taking away a negative, which translates to adding it. This becomes a plus. 2 plus 6 is 8. We can simplify this fraction. I can divide both the numerator and the denominator by 4. So when you do that, we get negative 1 over 2. And that's our slope, negative 1 over 2. We rise, quote unquote, negative 1, which means we go down 1 over 2, down 1 over 2, down 1 over 2, etc. Okay, so then we can classify this line, classify the slope as negative slope. Okay, the one from this little picture up here, this would be a positive slope because it's going upward as we read from left to right. Okay, This one's negative because it's going downward as we read from left to right. Okay, go ahead and try part C and D on your own, and once you get those, move on to the next video.